Okay, so guys, this is F3, and the problems on this particular phase, I decided to put them all together because so there used to be this way that I taught how to do these types of limits where you had to recognize that these limits were actually derivatives. They were actually themselves derivatives. So I'm just going to really briefly tell you how we used to do this and then show you why when I realized, oh my gosh, we could just use L'Hopital's rule, it makes it so much easier. So in order to do a problem like this is number 4 from practice. I used to teach it like this. So knowing that this is the limit definition of the derivative, okay, f prime of x is one of the limit definitions. There's the x approaches c is the other one. So the kids would have to recognize this. So notice this. So this is the original problem. A property of limits, guys, is that you could actually pull constant multiples out. So you could pull coefficients out front of the limit. So I just pulled, it's having the 9 in the bottom is like multiplying by, it's like having a coefficient of a ninth or a multiple of a ninth. So I pulled the ninth out. And then you could see that this, and by the way, I don't want you to do this. I just want to show you how beautiful L'Hopital's rule is here because this is what we used to do. If you could follow this logic, try to, okay, because that'll, just solidify your understanding of this limit definition. But try to stay with me, but if you don't, it's no problem. So then the kids would look at this and they would say, all right, this looks, since h is approaching 0, I've got h in the bottom. It looks like it's probably some version of this formula. So then they would figure out that, this is actually like this formula, all right, where 4 goes in for the x, all right? So it's this formula if f of x is 3 to the x, all right? So that'd be f of 4. Like that would be f of 4 right there. And then they'd recognize, oh, okay, well, this is just the limit definition of f prime of 4. Okay, so that is just f prime of 4. And then they would, because f prime of x would be this, because that's f of x, then they would do f prime of x, plug in 4, and then they would get it. Now that is a lot, it's like a lot of logic and mess, but with L'Hopital's rule, we don't even need it, okay? So here we go. Anytime you see a limit, you try direct substitution first. Okay, so instead, you don't have to recognize what I just did. Okay, I just wanted to show you that. So now you'll appreciate this even more. So you just go right to direct substitution. So this is 0 goes in for h. So this is 3 to the 4th minus 3 to the 4th all over 0. That's 0 over 0. Therefore, by L'Hopital's rule, okay, only, don't write it out though on a test. This is equal to the limit as h approaches 0, okay, derivative of the top over derivative of the bottom. So h is just like x here. So the derivative of the bottom is 9, okay? The derivative of 9h is 9. Because h is just like x here. Now the derivative of the top. Guys, we got these two terms. This term here, 3 to the 4th, is a constant. All right, it's just a number. The derivative of a constant, the derivative of a number is 0. Okay, so that part is 0 there. Now for the derivative of this part, of this term, I do need chain rule. 3 to the blank. The derivative of 4 plus h, that's just 1. All right, think of like 4 plus x. That derivative would be 1. Times the derivative of 3 to the blank is 3 to the blank times natural log of 3. And then what goes back in the blank is is that. Okay, so the derivative here is 3 to the 4 plus h times natural log of 3. And then you do direct substitution again. So I plug 0 in, and we get 3 to the 4 plus 0 times natural log of 3 all over 9. 3 to the 4th times natural log of 3 over 9, which is what we would get from this long drawn out process, which previous students of mine had to learn. Okay, so there is that. All right, let's do this one. All right, this one comes from the limit definition of the derivative when where x is approaching c. But you'd have to factor out a negative from the bottom in order to get it in that form, but we don't even need it because we've got L'Hopital's rule. So first, you do direct substitution. So that's natural log of 2 minus natural log of 2 over 2 minus 2, 0 over 0. Therefore, by LHR, only for practice. This is equal to the limit as x approaches 2, the derivative of the top. The derivative of natural log of x is 1 over x minus the derivative of natural log of 2. Natural log of 2 is a number. It's just a number. If you plug a number into a function, just another number comes out. Okay, so this is a constant. Its derivative is 0. 2 minus x, that derivative. Derivative of 2 is 0. The derivative of negative x is negative 1. Okay, and then you're plugging in 2. So this is 1 over 2 over negative 1. Negative 1/2.